So a piecewise function obviously is a function in pieces, but the big idea is that you take each line and it's its own unique piece. So like this line up here, this is 8, where x is less than or equal to -1. Here's where x equals -1, all this around here. So this function is only going to happen at -1 and at places less than -1, so over here to the left. And it's a function of a constant 8. Actually, let's change that because that's going to be too high for me to grab. Let's change that to a 2. Because 8 would be just too high up. A constant function of 2 means the line just goes straight across at y equals 2. And then it's going to stop right here. I'm going to put a closed dot because this is where this piece ends. I reached x equals -1, so that's where that piece ends. Yeah, so I guess another way of looking at a piecewise function is that you can take each piece and say y equals 2. Graph that line only where x is less than or equal to -1. Then the next piece we're going to go on to is the graph of y equals 2x. But we have to obey those constraints again, that x only happens between -1 and +4. So here's where x is -1. Here's +4 on the x-axis. That's the only place where this graph can happen. And the graph of y equals 2x, let's color code this one actually. Let's make this red here. The graph of y equals 2x has a y-intercept of 0, and then it rises 2 and runs 1. It rises 2 and runs another 1. So this is the graph, but I'm going to put an open circle where the graph starts at x equals -1 because, as you can see here, there's no or equal to symbol. We put a closed dot on this one because it has a line underneath. We got to keep an open dot because it can't exactly equal this point right here. But this is the graph, and it's supposed to stop when we get to +4. So this is where x equals +4. It's just going to keep going out this way. And I didn't really hit all the lines. It's hard to draw with my finger here, but you get the idea. Oh, and sorry, this shouldn't be an arrow. We're going to have a closed dot when we get to the end. There's no arrow here, okay? Because this is a line segment. It's not a line, it's not an array or anything like that. The line stops between -1 and +4. Because we're going to pick up a new piece when we get to x is greater than 4. So here's where x is 4, this imaginary line right here. This new piece is going to be everywhere to the right of +4. And this graph in blue is the graph of y equals -4 minus x. Okay. So I'm going to draw some points here, but they're not going to be on our final graph. It's just to help us get an idea of where the graph's going to be. And actually, again, to make this fit, I'm going to change that to be a +4. Okay. Because it won't fit on our graph otherwise. 1, 2, 3. +4 starts up here. And remember, these dots are about to be erased because I'm not supposed to draw this graph for anywhere unless x is greater than 4. This is x equals 0. That doesn't obey that condition, so the blue line shouldn't be happening here. But I'm drawing that dot to help me have an idea of where the line goes. Because it has a y-intercept of 4, and it goes down 1 to the right 1 because it has a slope of -1. So down 1 to the right 1, down 1 to the right 1. Here is where I'm going to make my first closed dot. And then I'm going to go down 1 to the right 1 and down 1 to the right 1. This is where that piece is graphed. And it is a line because it keeps going to infinity. X is greater than or equal to 4. It doesn't have an endpoint. So this, and this represent the graph of the piecewise function because this is the graph of y equals 2 when x is less than -1. This is the graph of 2x when x is between -1 and +4. And this is the graph of 4 minus x here in blue when x is greater than or equal to 4.